So we got old Billy Bo Bob back. Here we have Billy Bo Bob, and he found a table, and the data in the table was about his favorite redwood tree. And he wondered if he could use this table to predict the height of the tree at other points in time. So there's our situation. So we are given this data table. It only has 3 pieces of data on it. But in class, we did talk about the fact that this data table will represent a linear function, in that we will have an x value and we will have a y value. And when we input a certain x value or years, we will get a height of a tree output. So in 3 years, we have a tree that is 17 feet high. In 4 years, we have a tree that is 21 feet high. In 5 years, we have a tree that is 25 feet high. So we are being asked first, how much did this tree grow each year? So since we're looking for growth, we really want to look at our height of tree in feet, or our y values. And so our table is growing by 1 year, right? Because for each x, every time x adds 1, let's see what's happening to our y's. So between 17 and 21, we see a growth of positive 4. Between 21 and 25, we also see a growth of positive 4. So what we could say about this is that each time our year grows by 1, our tree grows 4 feet, or each year the tree grows 4 feet. Now let's talk about B and C, actually. C will be a part of this as well. I'm going to kind of do B and C at the same time. So we're being asked how tall our tree will be 2 years after it was planted, 7 years after it was planted, and also the year it was planted, or year 0. So what I'm going to do for this is I'm going to make a table. I'm going to make a new table. And I'm going to include these new x values. So we have our x's and we have our y's. So let's start with year 0. And then we have year 1 and 2 and 3 and 4 and 5 and 6. And I guess that we also wanted year 7. Here, I'll add on a little 7 on there too. So we are already given years 3, 4, and 5. 17, 21, and 25. And we know that our tree is growing 4 feet each year, which also means that since we see a growth of plus 4, that means if we want to move backwards, we have an arrow going the opposite way, we can just say, well, the previous year, it was 4 feet less. So we could say, well, for year 2, that's 17 minus 4, which equals 13. For year 3, or I'm sorry, year 1, let's do year 1. That's 13 minus 4, or 9. Which means that year 0, we would do another subtraction of 4 right here. Year 0 would be 9 minus 4, or 5. And I had some students be like, well, in year 0, how could it have height? And so let's just remember we're looking at years after planting. So planting, this just means that this tree was not planted as a seed, but it was planted as a 5-foot tall little baby tree. And keep that in your mind as you're working today, because there will be an important piece of information that will teach us about when this seed started growing. But that's for later. And we can also finish this table by moving forward. 25 plus 4, we're going to start adding 4 again because our x is increasing. So when x increases, our y increases. So in 6 years, 29. In 7 years, 29 plus 4 is 33. So every time our x increases by 1, our y increases by 4. when our x decreases by 1, our y decreases by 4. And then none of us really got to this in class, but we're asked to estimate the height of a tree 50 years after it was planted. So I'm actually going to start that with your problems today. Good luck with your work today. Let me know if you have any questions.